Okay. So what I'd like to do is quickly do a recap of characters. And then this is the tutorial. So we're obviously, for today, we're dealing with while loops, and then 2D while loops, and then enums and structs. So that's what we'll cover. And then where's the lab? So we have interesting, a question on don't be so negative. So what are we doing? So we're entering a number and then printing out whether it's positive or negative or 0. Okay. Count up or down. We're printing 5 numbers based on the input. We're printing 0 to -3 based on the input. Okay. Vector sum. Okay. Coordinates. Fancy pattern. Oh, that one looks fun. Okay. So that's the lab. It's a bit of a taster of what we're doing. A lot of looping. Okay. Quick recap on chars and ints. Can you see that okay? Zoom in. Too much. Okay. What does this line do? Cool. So, and what kind of variable is it? The char. So we create a char variable, a character. We call it 65, just a name, but I call it 65 because I assign it a number, 65. Now I'm assigning a number to a character. Does that blow anyone's brains? Does that sound illegal? Kind of, right? It sounds like, what are we doing? That should be a character like a B or a C or a D. But this is the point. Characters are actually numbers. Dun, dun, dun. Okay, so I can actually assign a number to this character called 65. And then I can call this function printf and then print out the number 65 as a character. So let's print out the number 65 as a character and then give it %C and then 65. Who knows what that will print? A or B? Capital A or capital B? Okay, any other ideas? And who doesn't know? That's fine too. A or B? Cool. So we all think it'll print A. That's great. And that's exactly right. It'll print an A because the ASCII value of 65 is A. Okay. Why don't I even compile that? BCC-O chars. CD week 3. Oh, interesting. Okay, there we go. Let's print out the number 65 as a character, and we got capital A. I think we all said lowercase a, didn't we? Almost. Okay, so now we're up to the next bit of the code. So I initiate a new value called mychar. It's a character, yeah? And then we print f, enter a character. We do scanf to scan in a character and store it in mychar. All with me so far, yeah? What should I enter in? Give me a character. B? Cool, we'll enter B. And now next line of the code is the character is this, mychar. And then mychar, which is what we just scanned in B, the decimal value in ASCII is this number. So we will get what number the B corresponds to on the ASCII table. Cool? Awesome. Let's see what happens next. Okay. So there we go. We got the character is B, enter a character, the character is B, and my character's decimal value in the ASCII table is 98. Does that make sense? Cool. Let's have a look at an ASCII table. 98 on the ASCII table. 98, here we go. Decimal, character, B. Yep.
You know how you did percent D for a char? Can you like use like a char with percent C and D?
Yes. So if you have a char initialized to 65, if you do printf %d, you'll get 65.
Oh.
If you have printf %c, you'll get the ASCII value of 65, which is A. Cool. Okay, so what is that? So now we can look at how we can manipulate letters using their decimal or ASCII value. Yeah. So if I look at this code, right? If my char is greater than or equal to 97 and less than or equal to 122, what's going to happen? What does that mean? What does that actually imply? Let's have a look at those numbers on the ASCII table. So the first line is the first condition, if the char is greater than 97. So 0, where's 97? Here. So if it's greater than this, and it's less than or equal to 122, 122 here. So that's basically saying if it's greater than A or less than or equal to Z. So what does that mean? What kind of character is it? A lowercase alphabet character. Cool. Okay, what about if my char is greater than or equal to 65 and less than or equal to 90? So let's find 65, here it is. So it's greater than or equal to A and less than 90. Where's 90? Here. Less than or equal to big Z. So what does that mean our character is? It's a capital alphabet letter. Cool. What about this one? If it's greater than or equal to 48 and less than or equal to 57, what does that mean? 48 here, 0, 57, 9. It's a number. Cool. So that's how we can figure out what kind of character we have using ASCII values, okay? Now, we can do this in an even cooler way, okay? Right now, we were comparing to 97, 122. It's pretty hard, you were like, oh, I think it's A, it might be a B, or it might be capital A, it might be a capital B, right? I don't remember either. Actually, I do, but, I've done this for a while. We can compare directly to characters. So if my char is greater than or equal to A, lowercase, and if it's less than or equal to Z, then it's a lowercase character, okay? So that's the exact same thing. Does that make sense, guys? Cool. So we've gone from using numbers to actually comparing directly to the character itself, and that is allowed. Typically, you think you can only compare 0 and 1, or numbers and numbers, but you can compare a character and a character because they are actually underneath the hood numbers. Okay? Cool. And this is kind of like one of the key things that you needed for message cipher. We are doing addition with characters, which just sounds like, what? A plus B? That's not possible, but actually it is. Okay? Last bit, letter arithmetic. If the if the character is a lowercase character, that's what this line is saying, yeah? If it's more than an A and less than a Z, we can find the index. So think of the alphabet index as something like this, right? So we've got A, B, C, D, E, F, G, blah, 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 yeah? This is what have I said it as? This is the first letter, the second letter, the third, fourth, fifth, sixth, seventh, yeah? That's what I mean by it's index in the alphabet, okay? So if we have a lowercase character, to calculate what index the character is in the alphabet, we can go my char, which is, say the character is B. What index in the alphabet is B? 2. Yeah. So if we take B, which is 2, B is, what is B? We'll do lowercase b, because that's what we are dealing with. 98, and then we subtract we subtract an A, which is what we've got here. So that's 98 minus 97. What's that? 1. And then we add 1. We get 2. Cool? Oh, cool. I like those ors. Nice. Okay, let's do another one. Let's do capital letter. We've got a capital C. We go capital C is 67. Yep. Minus capital A, 65. What's that? 2. Plus 1, 3. What letter of the alphabet is C? It's 3. 3, exactly. Okay, cool. Any questions on that? Let's run the program one more time. So we've got, give me a character, any character. D. Let's do a more interesting one, I. Capital I. Okay, so the ASCII, the decimal value of the character in ASCII is 73. Let's check that. 73, da, 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 I. Nice. And then the index of the alphabet is 9. A, B, C, D, E, F, G, H, I. 9. It works. Cool? All right, let's move on. Lab 3. Okay, loops. Who feels comfortable with loops? 1, 2, 3. Okay, few nods. Yeah. Okay. We don't have enough people to really do this. Let's read through this together, okay? What was your name? Clara? Lara. 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 Okay. Can we talk through this function together? So what happens in this line? I can zoom in for you. Ta-da. What happens in that line? It looks like we set I, we just create a variable I. Yeah, and what kind of variable is it's an integer, which is a number. Okay, cool. So we set I is 5. Now we say while. Cool. So tell me, this is like a statement, right? Like the statements can have a true or false value, right? I am a boy. True. This is a whiteboard. True. This is a time traveling device. False, as far as I'm aware. Okay, Alex, yeah? This is a pineapple. This is a pen. Wrong, wrong. This is a computer. Okay? So, is this true? Is I greater than 0? Yeah, it is. Exactly right. So, that means we will enter in this while loop, okay, and do something. We can think of while loops as having this structure. While statement, brackets, do stuff. Cool? If true. While statement, if true, do this stuff. Okay? If false, you never get to do the stuff inside the while loop. Okay? And just up here, I've got some statements. The sky is green. Is that true or false? It's false. The sky is blue. That's true. 1 is less than 0. That's false. 0 is less than 1. 3 mod 2 equals 1. Is that true or false? It's true. Yeah, you probably also saw it anyway. Dang it. You're getting the answer because they're already there. Okay, it's true. Okay, so while statements. While, brackets, statement, which is either true or false. And then inside the brackets, the things that we want to do if it's true. Okay? So this is true. We just said I is indeed greater than 0. What are we going to do in this line? Print f%d new line I. So what are we going to print?
Number 5.
Cool. Great. So we print 5. Then we do I minus minus. What happens to I? What is I now? 4. Cool. Love it. We can all chime in now. Lara's doing a great job, but these guys are getting eager to get some action, it seems. Okay. So 4. What happens here? We get to the end. Where do we go? Back to the start, exactly. We aren't outside the loop yet. We are still kind of at the end. And now we go back to the start. We check our statement. I is 4. Is 4 greater than 0? True or false? True. So what do we print? 4. 4 minus 1. 3. Where do we go? Back to the top. Is 3 greater than 0? God, 5 is such a big number. Why didn't we? Okay, let's just say we got down to 1. Okay, so is 1 greater than 0? Yes. What do we print? 1 minus 1. Okay, cool. Back to the top. Is 0 greater than 0? No. Dun, dun, dun. Okay, where do we go? We exit. So we go to the other side of this bracket. And if there was more code, we just keep running down and do whatever else is there. Okay? Cool. Love it. Good team. Go team. Okay, let's have a look at this one. Oh, look at that 32. That scares me. That's a really big number. Okay, let's imagine that's like 2. So I is 1, while I is less than 2. Cool. Print F, what do we print? 1. Cool. I equals I plus 1. What does I equal now? Cool. We get to here. Where do we go? Cool. Is 1 less than 2? Oh, sorry. Trick question. I totally knew what I was doing. Yeah. Oh. It's actually I equals itself plus 1. So what was I? It was 1. So I equals 1 plus 1, which is 2. Sorry?
Then it'd be 4. And then it gets a 32.
Oh, that's an I. I apologize. Sorry, that's not a 1. But it's still 2, right?
Yeah.
So it's 2 to begin with. Cool. So it's 2. Is it less than... All right, say it was 3. Let's go with 3. Is it less than 3? Yeah. So we print 2. Now I equals I plus I. What is I? 4. Is 4 less than 3? No. Exit loop. Beautiful. Let's have a squiz and see if we can find an interesting one. I equals I plus 2. Minus minus. Okay, what's this one? What's going to happen here? So I equals 5. Is I greater than or equal to 0? True or false? True. 5 is greater than 0. Okay, what do we print? Cool. I minus minus. What is I? Beautiful. Go back to the top. Is 4 greater than 0? Cool. So what are we printing? 5, 4, 3, 2, 1, 0, including 0, because of that equal sign. What if that equal sign wasn't there? It would print till 1, because it will only enter. 1 is greater than 0. 0 is not greater than 0, so it wouldn't enter the loop again. Okay? You, my friend, are you okay? Or are you, is that looks of like I'm bored and got this, or I'm in pain right now?
I had like a 2-hour lecture.
Oh, I'm so sorry that you have to sit here and listen to me. Okay, let me look at this one. Well, that equals to T guy. Okay, that's an interesting one. Let's have a look at this one. E. What happens? Set I to 0. Set this thing called keep going to 1. Okay, so it just equals keep going. Does keep going equal 1? Yeah. Is I greater than 3? No. Do we do this? No. Cool. I plus plus. What is I?
1.
Yeah, 1. Exactly right. Cool. So what's happened? Have we printed anything out yet? Yeah? No. Cool. So is keep going 1? Yep. Is 1 greater than 3? No. Do we do this? No. Because it's the same sort of syntax, right, as a while loop. If statement, if it's true, do this. If it's not true, don't do this. Okay? Okay, so eventually we get to I++, where I is 4. Yeah? So I is 4. We go here. Is keep going still 1? Yes. Is 4 greater than 3?
Yes.
Cool. Keep going. Equals 0. I plus plus. 4 plus 1 equals 5. We go back to the top. Is keep going 1? No. Cool, huh? So what happens? Do we do this? No. Do we do this? No. Do we do this? No. We exit that while loop. Yeah? Because this condition isn't met. And now have a look at this, right? This is the power of good formatting. I can go like, where is the end of this while loop? And it's like, is it this one? Is it this one? I don't know. But because of formatting, I can go straight down and see that this is the bracket that corresponds to that while loop. That's the beauty of beautiful star. Okay, so we exit our while loop and then we print. What do we print? 5. Sorry, I went on a ramble and probably you all forgot. Yeah, question.
Is there some convention to not having the curly bracket on the next line after the statement?
There,
Or-
as in, have you seen that happen in stuff before? Or
Well, I write it with the curly bracket on the next line.
yeah,
Because-
well,
Is there some
yeah.
convention to
Do
not
that.
have it like-
Bottom
do
line
that?
is do that.
Okay,
Yeah, and you will have to for this course, unfortunately.
all right.
Yeah, there is a lot of code. I think historically that was written with it on the next line. Some formatters will actually put it on the next line. Ultimately, it's subjective. Outside of this course, do what you will, as long as it's consistent, I suggest. In this course, you have to do this.
So if I've already submitted code with it like that, I have to go back and change it to
No,
that?
not for labs, not for tests. Oh, you guys don't have tests anymore. For assignments, yes. But just resubmit your assignment this time. Have fun doing that. Okay, cool. Any questions on 1D arrays? 1D loops. Cool. Okay, let's move on to 2D loops. Let's have a look at what I've got here. Let's come back to this in a second, okay? Let's have a look through some code and see the output, okay? Size equals 3. We're going to do a 1D loop. Row equals 0, okay? Now, we're using row and col versus I and, well, just I in a 1D loop, okay? I equals row, or in math, basically X, right? And J, exactly, J equals column, or the Y value, okay? So we're setting size equal to 3. Why? Because I just want to print up to 3 or deal with small numbers. Otherwise, we'll have big stuff and be here all day, okay? So row equals 0. We're going to print a 1D while loop, and then while row is less than size. Is this true right now? Yep. We're going to print the number row. So this is basically what we did before. We get this output, yeah? Oh, yo, that's not fun. Okay, so we've now exited the code of the 1D while loop. Now we're going to do a 2D while loop. We're going to set size to equal 3. Row equals 0. Is row less than size? Yes, so we do what's inside the while condition. Okay, we print row equals a number. So what is that number right now? 0, beautiful. We initialize a new value, column equals 0, also referred to as our J value. Okay, while column is less than size, what is that true? Yes. We print F, a bunch of spaces, row equals 0, column equals 0, and then we pass in row and column, okay? Column equals column plus 1. So what is column now? 1, correct. So we go back to the top of our while loop. Column is less than size, true or false? Is 1 less than 3? Debatable, we seem. Plead your case. Why is 1 less than 3? Why is 1 not greater than? Okay, cool. We all agree that 1 is indeed less than 3, and math can continue as per usual. Okay, so we print row equals 0, column equals 1. Column plus plus equals column plus 1. So it's now 2. Is 2 less than 3? Yeah, cool. So basically we get this. We get this bit, yeah? Row equals 0, and then row equals 0, column equals 0, 1, 2. Okay, now we exit our inner while loop, the inner while loop, right? So here's our outer while loop. Here's our inner while loop. So we've just exited this because column is now equal to size, yeah? And then we do this. Row equals row plus 1. What is row now? 1. Okay, then we get to the bottom, and then we go back to the top, right? And we check this condition. Is 1 less than 3? Yeah. So we continue and go through again. We print row equals 1. So we get this line. Okay? See that there? You guys can see that, right? Yeah. So we initialize our value, column equals 0 again. Now, this is a really nifty trick. Take note of this. A lot of people tend to initialize column equals 0 out here. Okay? And then they forget that they have to reset column in their while loop. So don't do this. Just accept this as like law, what you must do, because it will just make your life better. No one told me that. I figured that out later, and I was like, my God, why didn't I get told that? Okay, so we reinitialize column to 0, and we do that so that we can print, well, we can traverse all values of the, I don't know how to describe it, the matrix, really. Okay, so column equals 0 again, row is 1. We print row equals 1, whoops, column equals 0. Yep, column plus plus. 1 is still less than 3, so we go in here again, we print row equals 1, column equals 1. Yep, column plus plus, we go through. 2 is still less than 3, so we print it again. And then eventually we get to 3. 3 is not less than 3, we exit. Cool? 2D while loops. There's an outer while loop, the inner while loop. That's it. Initialize the inner while loop's value inside the loop. Okay. So then we've got a bit of code that prints a 2D while loop in a different way. Yeah. So what happens here? What is the difference? Can you have a look at this code for me? I'll move this down. This code, this 2D while loop versus that one. Actually, let's do that. Yeah. Okay. Is anything else different? The answer is no. Sorry, it's just there's nothing else different. Exactly the same thing. What we've done is traverse a 2D. I don't even know how to describe this. Well, I don't know. What are we doing? We're just going through a 2D loop, really. It's the same. It's always the same. Anytime a 2D loop, you're working with a 2D loop, it looks exactly the same. What changes is what you do with the values, okay? So with this one, I was printing the values of the row and column in this format. Yep, so row equals %d, col equals that. And with this one, we're just printing row col with a comma in between it. But the actual 2D looping, exactly the same, okay? So when you get into the lab, let's have a look at like the lab, for example. Here's a question, print grid. So enter size 4, okay? Then we're printing this and this and this. So someone tell me what that represents? Row column, amazing, I love it. What about this one? Yeah, exactly. Row column, but column is bigger one, right? So what about this question? What is the value of row and column for that value? What's row? 4?
3 box.
3 but 4. 3. Definitely. I get what you mean in that if you're counting from 1, 1, 2, 3, 4, it's the 4th one, but it is the 3rd because in computer science we start at 0 basically. Okay. So what number row is this? 3rd row. 3rd row. Okay. What row number is this? The 0th, exactly. What column is this one? The first one. First column. Yeah. What column is this one? Second. Love it. What column is this one? The 0th. Okay. Cool. Makes sense. So what would our printf look like? I can even write it just here in a thing. Printf. What would our printf look like? To print something that looks like this in this format. Bracket. Comma, column, row. What am I missing? I feel like this is slightly wrong. Comma there. Okay, what else am I missing?
Bracket after D, and then end the quotation after.
Love it. What else? There's one more thing missing. Oh, what? Comma. Okay. Amazing. You guys are amazing. That's really good. Cool. Is anyone like not feeling good about that? Okay. But that is the syntax. That is exactly how you'd print that value. And then do we have to do anything special with our 2D loop? Or do we do exactly the same thing as what we just did before? Exactly the same thing. Wow, crazy. Okay. Okay. I'm going to skip this because I feel like you guys have just crushed it. Okay. Enums and structs. Anyone feel like they're just like totally the boss of enums and structs? You are. This is the boss. This is the man.
I have a question.
Okay. Okay. Hit us.
With the Zodiac one, I couldn't find anything online, but is it possible to print like the string in the enum or no?
No.
Yeah.
Yeah.
They want you to write 12 if statements.
Yeah. It
That's
sucks. I hated that question. Yeah. I totally agree. I didn't enjoy that
If you
question.
get it wrong, we didn't do it that way.
No, ultimately, all that matters is if you got the right output. How you got there doesn't matter. In this course at least. Cool. Okay, yeah. I honestly, between you and I don't get enums. We didn't have enums when I did the course, but it's supposedly to make your life easier. But you're all looking at me like it's not making my life easier. Okay, cool. Let's move on. Structs. Who feels comfortable with structs? 1, 2, 3, 40%. Cool. Let's do this. So I need a doc. Structs doc text. Okay. I want you to just, can we write down some adjectives that describe me? I'm a total narcissist. Say nice things. Like tall, I love it. Handsome, like kind, asshole. What? Huh? Soft spoken. Okay, like
Approachable.
approachable. Oh my god, you guys are so nice. Okay. Give me one more. Like maybe can you think of like some metric sort of stuff like fat? I don't know. We'll go fat, like huh? Thin. Okay. Yeah, we'll get there. Okay. Let's leave it that. Okay, so now let's categorize these things. What is tall, and is that how do we categorize that? Yeah, cool. So let's do that. I like that actually. True/false. Handsome. That's like looks. Like personality, kind, personality, soft spoken, demeanor. demeanor. I don't know if that's how you spell it, but that's cool. I don't know how to describe that one. Weight. Okay. So we have a characteristic and then like the category that it falls into. Let's do another one. What do we want to do? We can do UNSW or Comp 1511. Okay, we'll do that one. How would you describe Comp 1511? Torture, pain, suffering, not fun, tedious. Wow. Okay. Fun. Okay, I like it. I'm adding a bit of balance into the mix. That's cool. Okay. How would we describe like these words? They're all kind of the same thing. Let's call it like enjoyment level. Yeah. So that's the category. And these are like values that it could be, right? So we could have like this is like, let's call that one like height. Yeah. They're either tall, and that could be like metric or short. Enjoyment level, difficulty. Yeah. So these are like the characteristics. These are like the buckets into which these descriptions fall. Yeah. Okay. What is a struct? A struct follows this format. Okay. Struct. Whenever you're going to be coding a struct, it's going to look exactly the same. Struct, label, brackets, things. Okay. So if we had our example, things. So we're going to have like type and then name. Okay. Let's do struct Robbie. So we had me and we did like, we had height. What kind of variable would height be? An integer or a string or a character? Or a double. Okay, I love it. I love the precision. Height. What else have we got? Personality. What would that be? Like we'd want some sort of string, right? But we don't really have that yet. But let's just put that there. Personality. Like fat, weight. We can do like weight. What would weight be? Double again. Let's go int just to break it up. We'll have round numbers for weight. Okay, cool. So what have we got? We've got the struct. We've got the label that we're calling it, Robbie. We've got the characteristics inside, and then we can assign each of those values. So weight, 1,000 kilos. String, or personality, like total meaning, etc. Okay, and then what we have below is the same thing in a different context for a person. So we've got our struct of type, well, that we're calling it person, and then we're giving it these sort of descriptions, yeah? So we can give it a shoe size. An int, does that make sense? Like shoe size is a number. Height, double, love it, the precision, you guys are on it. And then a first name initial, okay? Cool. So, this is funny. That's someone I know, I guess. Okay, so we've got, we've created our struct person, yeah? So this is saying create a struct of type person and call it Samantha, yeah? So our struct that we refer to is called Samantha, and it's of type person, yeah? Make sense? Cool. Now to change, or to set Samantha's shoe size to 100, wow, Samantha's pretty big. We just go Samantha.shoe size equals 100, okay? To set their height, we set Samantha.height equals 2206. Now, why did we do the 0.6 here? Because it's a double, yeah. Would this work?
No.
Why? What would happen?
Say something about it being the wrong.
Yeah, exactly. C will yell at you and be like, you're using the wrong type. Exactly right, okay? So, and then this one, Samantha dot first initial S. Okay, cool. So what have we done? We've created a struct of type person, yeah, and called it Samantha. And then we've set the different values of our struct Samantha to be 100, 226, and S. Now, how do we print out those values? It's simple, just like this. We pass in, well, we print shoe size and then a percentage D. Oh, they're all shoe size. So what should this be? Shoe size. And then we pass in Samantha dot shoe size. Make sense? Now we want to print out height. What does this need to be? Now there's something wrong in this line. What is wrong? What does that mean? So what is percentage D for? Integers. Is height an integer? No. What is percentage? What is height? A double. How do we print doubles? LF. Exactly right. Cool. Is this right? Oop. What does this need to be for initial? First name initial. Correct. Okay, cool. We won't do that today. Let's compile. Any questions on that while I'm compiling?
Is this supposed to be a space or like?
In printf, this is formatting. Just imagine like this, right? If I didn't have the space there, it would just be shoe size colon 100.
Sensi for characters.
Yeah.
Yeah. I don't know. When scanning. So
Scanning. Yeah.
There's supposed to be a space after the words.
Great question. Can anyone answer that one? In a scanner, if we have a space before the C or the D, what does that do? Can you say that again for me?
Allows for white space areas.
Allows for white space area. What does that mean?
If you were to press enter or space.
Yeah, exactly right. So rephrasing what you said, which is completely correct. Putting the space in before %D in a scanf will allow you to press space, and then hit a number and it'll scan in okay. Okay? If you don't have the space in and then you hit space, and then 6, it'll just take in that first value, which is a space, and that's wrong. Okay? Now, what happens if you put a new line in a scanf?
Will you scan like this line?
No, actually, it just does weird stuff, which varies a bit. Don't put new line in scanfs. This happens so often, and it causes so much pain because you look at it and you're like, oh, it's a printf, it's a new line, that's fine, it's fine, it's fine. But then it actually just causes a series of issues, and it'll just do random stuff, and you'll be like, why is it doing that? And it's just because it's just totally cooking everything. Okay. Questions on structs. How do we access the value of, how do we access the shoe size of Samantha? If you were to say it. Samantha dot shoe size. How do we access height? Okay, cool. We create a new one. What's your name? Keaton. I knew it started with Keaton. How do we create a new struct called Keaton of type person? Or are you a person, alien? No. We'll go with person for today. What do I write? Struct person. Cool. We're creating a new struct called Keaton, of type person. Cool. Okay. How do I create Keaton? What do we want Keaton's shoe size to be? 200. Wow, really competing with our big shoe size over here. Okay, how do I do that? What do I write? 200. Okay. Lara, how do I initialize Keaton's height? What do I write? Well, what do you want it to be? You tell me.
Let's say 180.
180. Wow, big boy. Cool. That's how we do it. Easy, right? Enums. Ugh. This will take 1 minute. Can anyone see enums? There. It's like it's almost in alphabetical order. Okay, Opal card type, adult student concession. Okay, for 10,000 points. Who can tell me what will be printed by this program?
0, 1, 2.
Ding, 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 Keaton. Not just a tall guy with massive, massive feet. Cool. Exactly right. It will print out 0, 1, 2. That's like just a thing that you need to know, I guess. What is it useful for? I don't know. I'm sorry. I wish I had a better answer, but I guess something. You just need to know how to work with it. Okay. I guess it means something. I'm sorry. That's probably the worst answer I'll give you for about anything. I promise. This whole term. Ask me something complicated, I'll answer it. But I don't know. I don't know this one. Let's prove it. Okay. Enums.c. 0, 1, 2. Boom. Okay. I'd say it just allows us to save time doing something. Okay. Questions on structs, 2D while loops, enums, 1D while loops, the charter int stuff that we did.
Are structs like objects in like C# and stuff?
Yes, exactly right.
That's it.
Cool. So how can anyone describe a struct for me? How would you describe it? Like
Nest of variables.
a nest of variables, typically to do with something in common, right? So we were describing a person. We could describe UNSW, be like expensive, constantly wet, the weather, location, blah, blah, blah. This is sort of all the things to do with UNSW. And you could even extrapolate that out one level further. You could say struct of type university, and then you could have the state it's in, the city it's in, its ranking, its best faculty, etc. Okay, so it's just a way to store information about something. Okay, all right, that's it. Let's go.
On the left side.